Hello everyone. Thank you for taking your time to come listen to my talk. So my name is Shadrack Phetla. I work at DMT Gayabatra. And I'm part of the GSSA mentorship program for the year 2023-2024. So my talk today will be about geothermal energy in Africa and how it can be a solution to the electricity crisis. Okay, I just need to. Okay, just to give you a brief background about the company that I work for. So DMT Gayabatra is a subsidiary that is under a DMT Group, which is based in Germany. So DMT Group is the MT Group is it specializes in plant engineering and processing, civil engineering and infrastructure, mining and energy. So our office is here in South Africa. We're basically just a mining consulting company. As well, DMT Group is part of a larger multi-industry company called the TÜV Group, also based in Germany, which provides the engineering and natural resources. So just to get you on the contents of my talks, I will talk about the electricity crisis. I'll go through the fossil fuel and renewable energy. What is geothermal energy? Current developments, summary services that the DMT company provides for the geothermal energy, and as well show you some of the projects that have been conducted so far. So, as we know, electricity is a critical resource in Africa, with over 640 million people without electricity or the excess of electricity. In a study done by the African Development Bank, it has shown that most of these challenges are faced by the sub-Saharan African countries such as the West Africa, East Africa, Central Africa, and the Southern Africa, with over 640 million of the population in the sub-Saharan African countries without the access to electricity. That is 600 million, sorry, which is well over 43% of the total population. So this is referred to as the crisis because it affects health in terms of there's no new technological healthcare technologies that can be developed or provision of clean cooking. It affects the education system in terms of online and the lighting in the house for studying, communication, new communication tools, employment in terms of job losses. Without the access to electricity, there's no profit that in businesses, and therefore there's retrenchment which leads to job losses. It also affects the environment and subsequently leads to the economic declines. So these factors that contribute to the limited access of electricity in Africa are mostly due to financial constraints in terms of lack of funding, means there's lack of maintenance of the infrastructure, as well as a lack of development of expansion of the power plants. Another factor will be the population growth in Africa. The more the population grow, the more the demand for electricity and the less the resources available for access to electricity. So how can we overcome these challenges? It is very important that Africa, or the continent as itself, to provide access and increase the number of energy for all. So Africa must prioritize ensuring that affordable energy is provided for all. African countries must develop clear policies and strategies. International institutions should increase their support to accelerate the progress. Solar home systems and mini-grids are making a difference, but more still needs to be done. in terms of more resources to be implemented. So in summary, addressing electricity access in Africa requires concerted efforts, innovative solutions, global collaborations, and by prioritizing this issue, we can empower communities, drive economic growth, and improve the lives of the people in Africa. So Africa is mostly relies on fossil fuels to produce electricity. Fossil fuels has been historically a significant source of electricity in Africa, especially for countries with abundant coal and natural gas resources such as South Africa, as well as Morocco for their natural resources. So some of these power plants, coal-fired, oil generators, natural gas facilities have provided a substantial portion of the continent's electricity. So in terms of the United Nations Sustainable Development Goal number 7, it is a good initiative from some of the African countries which are taking part in ensuring that access is affordable, reliable, the sustainability and modern energy, ensuring access to clean and affordable energy, key to the development of agriculture, business, communication, education, healthcare, and transportation. So also, we know that Africa is blessed with abundant renewable resources. For example, Africa is home to 60% of the best solar resources globally. However, only 1% of the solar capacity is installed. We have the energy resource as well, which according to a study done by the PwC, Africa's technical wind resource potential is as high as 59,000 gigawatt, yet only 0.01%, which is just the fraction of that, has been utilized so far. So Africa also has areas with potential wind speeds of over 6 meters per second, which is essential to produce enough electricity for everyone. Hydroelectricity as well, there's 38 gigawatts of installed capacity. Potential hydrothermal, there's potential hydropower of 300 gigawatt in sub-Saharan African countries. But most of these resource is just sitting, it's not yet utilized. So going into the geothermal energy now. What is geothermal energy? Geothermal energy is essentially just heat that is generated within the earth. Just to disintegrate this term, geo just means, essentially it means earth. Thermal means heat. So generally it's just heat that is generated within the earth. It is a renewable resource from the decaying of radioactive elements underground and can be harvested for human use. The resources can be harnessed for power production, heating, and cooling without worrying about supply shortages. It is environmentally friendly in the regard that power plants use less land. So this energy is mostly utilized for direct heating of buildings, parking lots, sidewalks. It is also used to generate electricity through hot water and steam to drive the turbines for enough electricity to be produced. So what is the mechanism behind this, the production and the distribution of heat? So at 2.9 kilometers below the Earth's crust lies the hottest part of our planet, which is the core. The core's heat primarily results from the decaying of radioactivity isotopes such as the potassium-40 and thorium-232, as well as uranium. So these isotopes, as they decay, they emit enormous amounts of energy, and then the temperatures in the core increases to over 5,000 degrees Celsius. Therefore, heat from the core constantly radiates outward, warming rocks, water, gas, and other geological material. The The Earth's temperature then gradually rises for the surface, from the surface to the core. This change is known as the geothermal gradient. In most of the parts in the world, the geothermal gradient is about 25 degrees per kilometer of depth. If then the underground rock formations are heated to temperatures of well above 700 to 1300 degrees Celsius, they become what is known as magma, which is essentially just molten rock that is permeated with gas bubbles. Magma exists in the mantle most of the time and lower crust, and sometimes reaches the surface as lava. So how do we harness this geothermal energy? What are the sources where we can actually extract the heat from this energy? They're mostly found in geysers, hot springs, steam vents, underground hydrothermal vents, and mud pots, which are used for direct heating in buildings and sidewalks. Also, there's another source of extracting this heat, which is called the enhanced geothermal, which is extracted through drilling. So the method of drilling is essentially just using two borehole. You drill two borehole. One is for extracting heat and one is for reinjection of cold water into the underground reservoir to heat up again, and then it's a repetition of extracting and injection of water back into the earth. So there's not much water loss or a lot of consumption of water. So what are the current developments of the geothermal energy in Africa? There was a study done by Al-Babari et al. In 2022 where they constructed the first geothermal potential map of Africa using the geographical information system to estimate the geothermal promising areas within Africa. So a lot of weighted overlays methods were used to integrate various data sets. For example, the geothermal thematic layers, including the rock units and the faults, geophysical layers through heat flow derived from the aeromagnetic data and seismicity, and geothermal layers such as hot springs, volcanoes, and the other various sources of geothermal energy. So the geothermal energy then produced 14 has detected 14 high potential zones, as can be seen on the maps. So some are in the North Africa, the East African Rift System, as well as the Southern African orogenic belts. So the map of Africa will then be used for targets and exploring new geothermal renewable energy sites, and can reduce exploration costs and pinpoint investigation areas during preliminary geothermal studies. So the Council for Geoscience, CGS, has also done the investigation where they were looking for potential for geothermal energy as an affordable, reliable, and renewable energy for direct heating of commercial and residential buildings, as well as the University of South Africa, Dr. Azwindini Ernest Shibavalo, who was appointed as the ambassador for the South Africa to conduct geothermal energy and contribute to the International Geothermal Association database. So during the investigation by the CGS, there's been some drilling so far, which the other was done in Limpopo, in an area called Sibisa, and the other drilling were done in the Karoo Basin. So the drilling have showed that there's enough and potential geothermal energy that can be harnessed and exploited for human consumption. The East African Rift System is one of the largest rift systems in the world. as well as an interesting region because of its thin crustal layers and an active spillage of lavas. So it spans at a total of 6,400 kilometers up to 64 kilometer wide. And it starts from the Djibouti country to all the way to Mozambique. So in the East African region, a total capacity of 20 gigawatt is installed for all the energy resources. However, currently only 900 megawatts of geothermal energy is utilized in the region. Kenya and Ethiopia are considered as notable producers in East Africa currently. So historically, as I am speaking, I'm sure most of the people listening maybe have a thought that geothermal is a new concept, especially in the continent of Africa. However, this has been going on for many decades now, which the first geothermal electricity generation plant was done in the DRC in the year 1950. It was the first binary power plant in the world, which installed a capacity of 0.2 megawatts. And however, it was decommissioned in 1970 due to declining mining operations, which were primarily the supplying energy to these mining operations. Kenya in the 1980s was the second country to install a geothermal power plant with 45 megawatt capacity in Olgaria 1 power plant. The capacity has since grown to 880 megawatts for several sites. Kenya has continued to lead in geothermal development, representing well over 46% of electricity produced in the country against its installed capacity of about 28% in the year 2017. Zambia was the third country to install a geothermal power plant with a capacity of 0.2 megawatt ORC pilot plant developed in Kapasia. However, this development has not been commissioned to date, and this is due to mostly the absence of a transmission line, breakdown of the protection well equipment, basically just the infrastructure. So the North and West African regions also have potential for the harnessing of geothermal energy, as well as further south in the West Congolian belt. You can also get an anomalies that indicate a geothermal potential in the area, but not much has been pursued in these areas in the North and West. So just to summarize everything that I've spoken so far, geothermal energy resources will support better electrification, improve living standards, and transform the region's countries from a socio-economic development perspective. It is a renewable energy resource and therefore will contribute towards eliminating the carbon emission. It is reliable because it produces electricity consistently, regardless of weather conditions, such as if, for example, the solar energy, if there's no sunshine, then there's no production of energy or electricity, or with the absence of wind, then there's no generation of energy from the wind turbines. So the resources can be harnessed for power production and heating and cooling without worrying about supply shortages. It is environmental friendly. As I've mentioned earlier, it's the power plant uses less land. So a lot of potential can be seen for the geothermal energy. So this is just a conversation that needs to be persuaded for future references. So for the DMT services in terms of the geothermal energy, we are a company that specializes in providing expertise in the three phases. We'll start your projects from project planning in terms of to seeing if your project is feasible enough, the cost estimations, if it's socially accepted. It's all the comprehensive reporting, and moving on to the second phase, which will be the site investigation that include geological exploration and interpretation of data, to your 2D and 3D seismic evaluation, data processing rules, drilling monitoring, sampling, and logging as well. So from the site investigation, then we'll be moving to the third phase, which will be your construction. So operation planning, and all the way until your project is as running as possible. So in terms of the technology and resources that DMT provides, we have well-looking measurement trucks, which acquire data in the field, and then the data is then transferred into a software called Petrel. We use that to actually monitor your bore path as well as your heat flow. There's provision for downhole surveys as well to monitor seismic activities or the stability of your borehole as well. So DMT also has an analytical core looking system, which is called the anchor lock, for your drill core scanner. So it uses 4 multi-sensors, which are essentially automated. So this then you are able to interpret your geochemistry, you are able to interpret your mineralogy, and you're able to classify your rocks as well. So it's a machine learning tool that uses AI to actually give you better and high quality results for your drill core logging. So just some of the projects that the DMT has done in the past. Once it was done in Austria, in Vienna region, for the 3D seismics for exploration. So this uses essentially 4 vehicle groups that are 4 vehicle groups with 3 vibrational or sweep mode. So this thing is used more thoroughly for safety through the use of wireless technology and to acquire this digitization of customer interface for your DMT Survey View app. Another project was done in the Northwest Europe, which was used to the expansion of deep geothermal energy as a climate and environmental friendly energy resource. So this was the aim to generate enough and reduce carbon dioxide emissions by replacing fossil fuels through increased use for large infrastructure, which require high temperature heat supply to meet their base energy load. Another project was done in Germany for seismic borehole measurement within the Graham research project. So the VPS tools which you could see on the bottom left were used in the Graham research project to validate time depth conversion of the 3D seismic data and to improve seismic interpretation through the inclusion of 2 boreholes in the large scale model. So that will be the end of the presentation, and thank you so much. I'll take the questions from now.
Shadrack, thank you so much. That was a perfect roundup of where we are with geothermal energy. And if you ever want to become a lecturer, I'd say you are perfectly suited for it.
Thank you so much, Martina. Thank you.
Any
I'll
questions?
consider,
Sorry, Shadrack?
I'll consider becoming a lecturer in the future.
Are there any questions for Shadrack? Or comments?
I just have one question, but I'm sure. Can I go ahead, Nolene?
Please go ahead.
First of all, it was a wonderful talk, Shadrack. I don't think many people have actually presented on this topic, so it was quite fascinating. I probably mentioned this during your talk, and it's just that I missed it. But if you go back to your map where you showed the potential for geothermal energy in the different regions in Africa, I see, yes, this one, thank you. So I see there in probably the southern part of Limpopo, as well as the northern parts of Gauteng, probably maybe northwest as well. There seems to be very high potential according to your map. Is there a reason for this? I know with your Kenya, you said that can be attributed obviously to the East African rift, but in these regions, what could be the possible reasons for that?
Yes, so that is actually between the border of South Africa and Botswana. So apparently in that region, there's it's mostly occupied by the Kapval Craton. So beneath it, I will assume there's a lot of conversion of heat that is taking place, and that is why they were able to pick up the heat that is flowing within that region.
All right, thank you. Yeah, that definitely makes sense. Thanks, Shadrack.
Clolile?
Hi, Maureen. Hi, Shadrack. Thank you so much for your presentation. Very interesting. So, your clients so far have been international. Have you had anything from South Africa? Because you know that we're having a challenge, and this is interesting. So I'm just thinking, is government aware of this, and do they have access? Are these maps available? Because I think one of the things that maybe we might struggle with is just not knowing. I don't know how far has communication been between your office and probably South Africa's, those powers that be in South Africa in terms of looking at this as an option. I'm going to tag along to Kensani's question. You've got a very high potential in South Africa, and if that is so, why are we not using, or at least considering this as an option with the current challenge?
Thank you so much for your question. The Council for Geoscience has done a lot of investigation throughout the whole of South Africa, actually, for this specific investigation. So CGS is part of the Department of Mineral and Resource Energy. So all the information that they get, they had to report to the department. So I am sure that the government is aware of it. So it's just a matter of finding relevant resources to pursue this geothermal energy. But the only thing I would say it's not, it doesn't come cheap. Because of the investigation, there's a lot of exploration, there's a lot of drilling before there can eventually be any implementation and the extraction of the heat for electricity. So there's a lot of research that goes into it and a lot of cost on that. But it's a sustainable and a renewable resource which can actually last for decades to come if it's actually taken into consideration. So I'm hoping that the government knows about it and the maybe thinking of exploring and doing a little bit of implementation on that.
Yeah, I was about to say, how much is it? I'd imagine perhaps the
It's
limitation is funds. Maybe
yes.
they might not have the resources, or maybe looking at
Mhm.
how much is it in terms of cost to set up a project like this from inception until the full
So
scope is done.
yes. For now, I can't give an exact estimation of how much it is, because there's still gonna be a lot of I would say planning from the beginning of how much, you know, there's potential, or what is the cost estimation. So the value or a number, specific number, has to come from after doing a certain research on the area. So I can't be sure of how much, and I can tell you specifically.
All right. Thanks, Shadrack.
Any other questions or comments? Right, it looks like you're off the hook, Shadrack. Again, that was fascinating. So thank you very much for doing that for us. Also for being our first speaker of the series.
Yes, I think I had to break the ice, so one had to do it.
And you did it so well.
I did. Thank you so much.
There we go. You've just been asked to come to do a talk at UJ in Kansani. You can get together and have a chat about that. Soon you're going to be a world-renowned speaker.
Okay.
And also just to say to the rest of the crowds here that he's also been asked to do a talk, probably an online one in Zimbabwe as well. So that was before his presentation. So yeah, very well done. I'm Shadrack's mentor, so I'm very, very proud of what he's done.
Yes, Gail is my mentor, everyone.
Our next talks will be on the 10th of July when two of our mentees will be talking. So please join us again. You'll find the registration link on social media and on the website, as well as our calendar. So looking forward to seeing you on the 10th of July. Until then, keep warm and have a great afternoon.
All right. Thank you so much. Thank you, everyone, for attending.
Great. I'm going to end the meeting now. Shadrack, thank you again.
All right. Thank you so much.
Take care. Alrighty. Bye.
Bye.
There are a couple of, Shadrack, there are a couple of, oh, he's gone. Okay.